Welcome to a deep dive into how modern companies are finally trying to get a handle on all their data chaos.
This is a real challenge, isn't it?
Absolutely.
Yeah.
If you've ever felt just overwhelmed by all the different tools you need for, say, data engineering, machine learning, BI, or just struggled with keeping data governed across scattered systems, well, today we're navigating that tech maze.
Try to cut through that noise.
Exactly. We want to bring you the essential insights you need fast. Our mission today, to really unpack Azure Databricks. We see it as this kind of unified command center for data, ML, and AI. The goal is to cut through all the complexities so you can quickly understand what it's all about.
Yeah, and it really is a key platform in the modern data world. Azure Databricks, it genuinely helps teams tackle those really tough problems, big data, analytics, AI, but with surprising simplicity and, frankly, unmatched scale. What's really powerful here isn't just that it brings open source Spark into Azure. That's part of it, sure, but it's more about how it handles all the operational stuff, managing Spark clusters, security, scaling, things you'd normally have to handle yourself.
Right, the headaches.
Precisely. It lets data teams focus purely on solving the data problems, delivering actual business value, instead of wrestling with infrastructure.
Makes sense.
Let me give you a quick example. Imagine a big online retailer. They need to process sales logs, like right as they happen, in real time.
Okay.
Then maybe predict demand for certain items using machine learning models, and then push those insights, the actionable stuff, straight to their Power BI dashboard.
All connected.
All within one single integrated workflow, not this patchwork of different systems we used to see.
That really paints a picture. So, okay, for someone maybe just starting out or hearing about Databricks, what are the first few pieces they'd bump into? What are the fundamental building blocks here?
Right. Well, the first place you usually land is inside a workspace.
A workspace.
Yeah, think of it like your main project environment. It's where you keep everything organized, your notebooks, your jobs, libraries, ML models, all of it.
So like a shared folder, but smarter.
Kind of, yeah, but much more. Workspaces are really key for teams working together. You set permissions, share things, manage projects properly. Collaboration is built in.
Okay.
And inside these workspaces, you'll spend a lot of time in notebooks.
Ah, I've seen those, like interactive coding documents.
Exactly. They let you mix code, Python, Scala, R, SQL, whatever you need, right alongside charts, visualizations, and even just plain text explanations.
So you can query data and then immediately visualize it.
Yep. Write a SQL query, see the chart pop up, then maybe in the next cell, write some Python ML code to build a model on that exact data. It's super fluid for trying things out quickly.
Nice. And where does all this code actually run?
That happens on clusters. These are basically groups of virtual machines that Databricks sets up and manages for you.
The compute power.
Right. And they're really flexible. You've got things like auto-scaling, so they grow or shrink based on your workload.
Oh, that's handy. So you don't pay for idle machines.
Exactly. Or over-provision. Plus, you can get GPUs for heavy deep learning tasks. And there are ways to optimize costs, like using pools of ready-to-go instances so clusters start up faster and cheaper.
Okay, workspaces, notebooks, clusters. What else?
Well, to make things repeatable, you use jobs.
Jobs. Right.
These are essentially your scheduled or triggered tasks. Think about a daily data refresh pipeline, an ETL job, or maybe a monthly forecasting script. Jobs are how you automate that stuff reliably inside Databricks.
Gotcha. So you set it and forget it, hopefully. I remember one place where someone literally had to click a button every morning to run a script.
Oh, yeah. That's a perfect candidate for a Databricks job. Exactly the kind of manual work it eliminates.
Makes perfect sense.
Now, underneath all this is something called the Databricks runtime. This isn't just plain old Apache Spark. It's their own tuned, optimized version. And they're smart about it. They offer different runtimes for different jobs. There's a standard one, sure, but also one specifically for machine learning.
What's different about the ML one?
It comes preloaded with common ML libraries like PyTorch, TensorFlow, scikit-learn, saves you setup time. And there are even more specialized runtimes, maybe for genomics work or things needing lots of GPU power.
Interesting.
Then there's a really, really crucial piece for modern data platforms, Delta Lake.
Delta Lake. I heard a lot about that. What's the big deal?
Well, it essentially adds database-like reliability to your data lake storage. You know how data lakes can sometimes be a bit messy.
The data swamp problem.
Exactly.
Yeah.
Delta Lake fixes a lot of that. It brings ACD transactions, that's atomicity, consistency, isolation, durability. Fancy terms, but basically means your data updates are reliable. You won't corrupt data if something fails midway. Multiple people can write at once safely. Data integrity is key.
So no more corrupted tables from failed jobs.
Much, much less likely. And it enforces schemas, too, so you can stop bad data, like the wrong data type, from getting into your tables in the first place.
That sounds incredibly useful.
It is. And what's really fascinating here is how all these bits, workspaces, notebooks, clusters, runtimes, Delta Lake, they don't just exist side by side, they're woven together.
Integrated.
Deeply integrated to create this flexible but really solid environment for, well, all sorts of data challenges. It smooths out workflows that used to be super fragmented, needing like 5 different tools bolted together.
That cohesion sounds like a huge win. Okay, so we have the building blocks, but what can you actually build?
Yeah.
What core jobs or workloads does Databricks really nail?
Yeah, good question. Databricks basically excels across 5 main areas or workloads. And the key thing, again, is they're designed to work together, not in isolation.
Okay, what's number one?
First up, data engineering. This is a bread and butter for many. You're ingesting raw data, maybe using autoloader.
Autoloader.
Yeah, it's a cool feature. It automatically detects and processes new files landing in your cloud storage. Super efficient. Then you use Spark to clean, transform, shape that data, and finally store the results, usually in Delta Lake format.
Right.
A really common pattern here is using those multi-hop pipelines. People talk about bronze, silver, and gold tables.
Yeah, raw data to clean data to aggregated data.
Exactly. Bronze is raw, silver is cleaned and maybe joined, and gold is aggregated, ready for business users or specific applications.
Makes sense.
What's next? Machine learning. This is a big one. Databricks has MLflow built right in.
MLflow for managing the ML lifecycle.
Yep. Training models, tracking all your experiments, versioning the models, deploying them, the whole 9 yards. You can use popular frameworks like XGBoost, PyTorch for deep learning, scikit-learn for more traditional stuff.
And track everything.
Track metrics, compare runs, visualize results, and deploy models often directly from the platform itself. Very streamlined for data scientists.
Okay. Data engineering, machine learning. What else?
SQL Analytics. This is geared towards your data analysts and BI users. Databricks offers dedicated SQL warehouses.
Warehouses, like separate compute for SQL.
Exactly. Optimized for SQL queries. They give really fast performance, often sub-second for BI tools. There's a built-in SQL editor. You can build dashboards right there, and it connects smoothly to things like Power BI, Tableau, Looker.
So analysts get a familiar SQL experience, but on the same governed data.
Precisely. Same underlying Delta tables. Then number 4 is streaming analytics.
Real-time data.
Yep. Using something called structured streaming, you can build pipelines that process data as it arrives. Think data coming from Kafka, Azure Event Hubs, IoT devices, reacting instantly.
Okay, that covers a lot. What's the fifth?
The 5th is the really cutting-edge stuff, generative AI.
The LLMs and everything.
Exactly. Databricks is adding lots of capabilities here. Things like fine-tuning large language models on your own private company data.
Oh, interesting.
Or building RAG systems, retrieval augmented generation, using vector search to let LLMs answer questions using your up-to-date documents. And integrating with tools like Hugging Face, LangChain, or Azure OpenAI.
Wow, so right up to the latest AI trends.
Definitely pushing the boundaries there.
But what I find really interesting, as you said, is how these connect. It's not like 5 separate products.
Oh, no.
You could genuinely say, explore data with SQL,
Yep.
then have a data scientist build an ML model on that same data, and maybe trigger that model from a real-time stream that engineering set up.
Absolutely. That's the whole point. It unifies these diverse data tasks.
Could you maybe walk through a quick example? Like, how might a data scientist mix streaming and Gen AI in a real project, show that unified flow?
Sure. Okay. Let's think about a customer support chat. You could have the live chat transcripts flowing in as a stream. That's streaming analytics.
Right.
A data engineer might have a simple pipeline transforming that stream in real time, maybe just flagging chats with angry sentiment. That's data engineering. Then, a data scientist could take that stream of flagged chats. They might use generative AI to, say, summarize the long conversation instantly for the support agent who takes over.
That'd be useful.
Or maybe they fine-tuned an LLM on thousands of past support interactions to suggest the best responses. Or even build a RG system so the AI can pull answers directly from the company's knowledge base to help the agent.
And all that, the stream, the processing, the AI, happens within Databricks.
That's the idea. The data flows seamlessly between these different workloads because it's all on one platform, often using the same underlying Delta tables.
That integration is powerful. But, okay, you've got all this data flying around. Customer chats, sales data, maybe sensitive stuff. How do you keep it all safe and, governed? What's the security story?
That is a critical question, and the answer really involves two key pieces: Unity Catalog and Microsoft Purview.
Unity Catalog, that's Databricks' own thing.
Yes, Unity Catalog is huge. It provides centralized access control across all your Databricks workspaces, not just workspace by workspace.
Centralized, okay.
And it allows for really fine-grained permissions, not just who can see a table, but who can see specific rows or columns within that table.
Row and column level security. Wow.
Yeah, it's essential for many use cases. Plus, it gives you built-in data lineage. You can track where data came from, how it was transformed, where it's used.
Traceability.
Exactly. And it provides a single unified namespace, makes all your assets, tables, models, even files easily discoverable and consistently secured. It's the foundation for governance within Databricks.
Okay, so Unity Catalog handles governance inside Databricks. What about Purview?
Microsoft Purview complements Unity Catalog by extending that governance reach beyond just Databricks.
Across other Azure services.
And potentially beyond Azure too. Purview provides cross-service lineage. It can track data connections between, say, Azure Data Lake Storage, your SQL databases, Power BI reports, and Databricks.
You see the whole picture.
The whole end-to-end flow. Purview can also automatically scan and classify sensitive data, like spotting credit card numbers or PII, and it helps enforce broader compliance policies and generate reports across your entire data estate.
So they work together. Unity Catalog for deep control in Databricks, Purview for the bigger picture across services.
That's a great way to put it. Together, they offer this really robust end-to-end visibility and control, which, let's be honest, is absolutely critical today, especially when data is spread across different teams, different clouds, different domains. You need that trust and compliance layer.
No question. That comprehensive control sounds vital for any serious operation. Okay. So we've talked about the parts, the workloads, the governance. Let's try to put it all together. Can we sort of visualize the whole thing? Paint a picture of how data typically moves through this system. An architectural blueprint, if you will.
Yeah, let's sketch that out. Okay, picture this typical flow. Your raw data could be anything. Click streams, sensor data, transaction logs. It usually lands first in your data lake storage, like Azure Data Lake Storage, ADLS.
Right, the landing zone.
Exactly. Maybe simple ingestion jobs put it there. Then tools like Autoloader efficiently pick up those new files.
Now you're right.
That data gets processed using Spark, maybe in notebooks, or increasingly using Delta Live Tables DLT pipelines.
DLT, what's that quickly?
Delta Live Tables basically makes building those reliable bronze, silver, gold pipelines much easier. Declarative pipelines with built-in quality checks and monitoring. Really neat.
Got it. So data processed by notebooks or DLT?
Yeah, and the clean, transformed results land in those versioned, governed Delta tables.
Managed by Unity Catalog for access.
Precisely. And this is where that unification really clicks. These Delta tables become your reliable source of truth.
Single source of truth, the dream.
It's closer than ever. And from there, everything plugs in. Your BI dashboards pull from those tables for reports. Your ML models train on them or use them for predictions. APIs might query them for real-time apps.
All hitting the same governed data.
Yep. And all the while, Unity Catalog is enforcing who can see what, and Purview is tracking the lineage, seeing how everything connects across the whole landscape.
That makes sense.
And this basic architecture, this pattern, it supports everything we talked about. Batch jobs, streaming data, SQL queries, AI workloads.
And it scales.
Massively. It's designed for scale from, a startup processing a few CSVs a day, right up to huge Fortune 500s running complex LLM workflows on terabytes of data.
That is the aha moment, isn't it? Seeing it all click together.
Yep.
Not just powerful tools scattered around, but one integrated system handling the whole data lifecycle.
Exactly. Cohesive.
So if we were to wrap this up, summarize what we've really dug into today, Azure Databricks, it's clearly way more than just a place to run Spark.
Oh, much more.
It's really this complete platform. Secure, scalable, built for collaboration, handling modern data needs from start to finish. It seems to brilliantly knit together data engineering, machine learning, BI, that crucial governance layer, and even the latest generative AI stuff.
Yeah, that integration is key.
And it feels like it's really built for teams, trying to get engineers, analysts, data scientists, architects, all speaking the same data language, working off the same platform.
Absolutely. And, having that kind of integrated platform, it fundamentally changes how companies can actually get value from their data. You move away from those frustrating silos towards a truly unified data strategy. It's a big shift.
It really is.
Which I guess leaves a final thought for you, the listener, to mull over. In this world where we're just drowning in data, right? How much potential, how many insights are just sitting there locked away because the tools are fragmented or the teams aren't connected?
Mm.
What could you actually unlock if you had that shared language, that unified platform to finally bring it all together?